Shall we start?
Okay. Uh, yeah.
Yeah, if you want me to wait, I'll just wait.
Just like we'll start in like more 3 minutes so that.
Okay, all right, sure.
So I think we can get started. Yeah. So hi, good afternoon, everyone. So welcome to the AFour's System Community Program. Uh, Today is the third session in this series. So in the first session, we have seen Linux fundamentals and touched base on file system. In last session, we covered network attached storage, and in today's session, we'll be covering SAN, that is storage area network. We'll touch base upon what is SAN, what are different protocols, and maybe the use cases for SAN, and we'll be seeing those. So I have Ravi Kumar Tripathi with me, and so he'll be conducting today's session. So thanks, Ravi, and without any further delay, we can get started.
Thanks, Meenal. Hello, everyone. So, as Meenal suggested, and so this is today's session will be covering the SAN basics. There are a lot of things which we can cover on the SAN side, like having a deep dive into the protocol, uh, how these SAN can be accessed via client. There can be multiple configuration depending upon the various distros. Like Linux, multiple distros are there, and Windows, many versions are there. So that will be more like in-depth session. But for this particular webinar, what I have tried is that just to have a basic knowledge of how the block level system works, how the storage accesses the SAN, and how the application server, how the access workflow happens. Okay, so let's start. So this is something that why this is the information why you should be attending this webinar. and who can be part of this community and what is the expectation with this now. So let's start. So topics will be what I'll be covering today is that what is block level storage, the SAM basics, SAM terminology. So I'll be covering few of the terminology and try to describe them so that people are familiar. The protocols which are used in SAN, and I'll be discussing about how we can access SAN via clients. And yeah, so feel free to have any question at any point of time, so that it is more interactive. Okay, so as I mentioned, before moving, what is block level or SAN, how it is being implemented, what is terminology? First, we need to know how the access workflow or the IO workflow will be there for SAN. So in this picture, if you see that there might be multiple clients which are, which are connected to each other with the LAN. With this LAN, we can access multiple application server like server A, server B, and server X, which are exposing or providing with various applications. Now, for these application servers, the storage part where the application data has been stored, that will be connected via SAN, and SAN itself will be having the type of storage and will be offering the block level services to these application servers for their storing needs. Okay, so that's the basic design of the how the access will be. Okay, yeah. So as Meenal mentioned in the last webinar, we had a discussion related with NAS. So NAS is more like a file level storage, while the topic, the SAN we are discussing it is a block level storage. So first thing is that we need to understand with what is block level, what is file level we usually call in storage. So as block level, which is different from file level, is that the whatever the disk or the drives you have on the storage side, so that individual disk or drive can be divided in different blocks, or even a single disk can be divided in smaller blocks, which we used to say LUNs. And these LUNs or the volumes or the raw volumes has been exposed to the clients for their use. Now, what is the difference? Difference, if you see the file level storage, the operating system which creates the file level structure sits on the server side. Like if I have an NFS server, which is file level server, it creates its own file system and then creates some volume and then expose it to the client. Now, block level is providing you the raw volumes, or the, say simply you can say disks via defined protocol to the clients. And now this is client's responsibility or the client's wish, whether that client or client want to use this disk or storage as a raw volume, or it can create a file system. Like if it is a Linux client, what it will be doing is that it will create a file system ext3, ext4 on that LUN and just have the file system and start using. So the file system overhead, it is not on the server side in block level storage or in SAN, it is on the client side. So that's the one difference. Another difference is basically you can say is that you can have direct mapping from one particular drive or LUN to a specific client. So we have one-on-one or direct communication happened, and which of course is it's a faster and more reliable. As far as the operations or the IOs are concerned, that those are also faster than file level, because it's because the each SCSI operation, or say like read or write any operation, those SCSI operation do have the information of a particular block to be modified or read from that particular block. So in that case, what happens in the file server, the whole file itself, when it has been read or being written from some client, the whole file is in use. While in block level, the changes where the changes where it needs to be appended, edited, or from read from, those blocks will be modified and changed, and that's why it is faster. Okay, so feel free to have any questions if you have. So yeah, what I have mentioned here is that we have raw volumes or LUNs on the storage. So the workflow will be like block storage or SAN will be creating uh, LUNs, and they are exposing these LUNs to the host, and host, depending upon their operating system, they'll be adding those LUNs. Either they use raw volumes or their file system they want to have and start using the storage. So block level storage is usually deployed in SAN. Each block in block level storage system can be controlled as an individual drive. Just for an example, if you have a drive like 4 disks, so each disk can be differentiated as a different block. Or say like you have a single hard drive, then single hard drive also can be divided into different blocks, so that you can say like you have 1 TB for a hard drive, and you have 4 clients which you want the storage to be shared of 200 GB each. Then you can create a 200 GB LUN and assign that LUN to host 1, host 2, host 3, host 4, like that, and they start using it. So each 2 GB will be a LUN, and each 2 GB will be a so-called block. There are defined protocols which has been transporting these commands, SCSI command and operations. So that is fiber channel protocol, the FCP, and iSCSI. Okay. So with these protocols, these storage blocks are visible and accessible, and it has been managed by service-based operating system on the server side. Okay. So I'll just have a pause for a second. If you have any questions, then.
I don't see any questions from audience as of now. So, of course, maybe if I would like to ask, like, what will be the use cases do you think this SAN will have? Of course, like faster access, bigger block level storage, and as a storage. But then any other thing, any other use cases? Can you just elaborate?
Yeah, sure. So basically, the majority of the use cases will be in the data center, where you have like, so just for an example, you can say that you have 4 application servers and 2 file servers, and hundreds of the user will be using. So you need required some virtual machines there. Okay. So for application servers, which require higher throughput, reliability, and faster storage, then whatever the storage those application server are using, those will be block based, that is SAN. Okay. So whatever the data store I'll create for them to use for the storage, that will be block level. So that's the one use case, because of the redundancy, fast reliability, and the speed. These will be using SAN. And on the other hand, so like for the file server, which if you have the 2 file server, 3 file server available in your network, then those are having the unstructured and the unstructured data, which are the files. So those don't need to be had that faster, and those can be used as a NAS or NFS storage. Okay, does that answer?
Yes, perfect. Thanks, sir.
Okay. Yeah. Okay. Okay. For moving next is what are the pros and cons? What are the features for SAN? So as I just recently mentioned, is that the availability of applications, like we can create multiple data paths or channels to have the IO workflow for a specific application for having redundancy. so that it is more like highly available feature. So most of the applications like DB applications or any web server or these type of applications which don't uh, require any downtime, and they want everything to be running on uh, you know with a great availability. Those can be used. Those will be using SAN. Other than that, like it is SAN is also being used for having better application performance, since like as I mentioned that there is no operating system or file system overhead. Sorry, not operating system, but file system overhead on the server side, on the storage side. So it's more like on the client side. So it is way the performance will be definitely much faster. So SAN also giving you the feature for better utilization of the resources. So like there is no redundant data available there. You can enable the dedupes, and there are other technologies as well. But so as far as the utilization and effectiveness is concerned, SAN is far more better than NAS. Okay, next, the transportation, data transportation. See, so for the protocols we using here is that the FC and iSCSI. So iSCSI will be using that Ethernet, but as far as the FC is concerned, it's way faster than the Ethernet. So that's why the data transportation is more efficient and reliable and faster. Okay, this is another use case, Meenal. So say like I want to have a few of the machines which requires boot up.
Mhm.
Okay, from network. Those in those scenario, SAN and or the block level will be used because it provides that feature, because file level will not be able to provide you a boot up feature. So that's an added advantage with this.
Okay.
So next is that, like as I mentioned, the individual formatting where we are not having any overhead related with the file system. And another thing is that you're also enabling the virtualization for storage. So overall, SAN is basically, it depends upon the use case what you're looking for, but SAN is better than file server, but not widely used as NAS is, because most of the data we are creating is the file level, or the pictures or the movies, these type of data. So majorly NAS is being used, but SAN is having better throughput, reliability, and those features as I mentioned. Now there are cons as well, just because of these um, complex topology and overhead of having fabric switches or spatial switches, for the speed and these stuffs, the cost will be associated with there. Another cons will be that the data sharing, like in file server, we have a data sharing which anyone can use. But in the LAN, it is more like in SAN, it is more like peer-to-peer communication. You can have a group of uh, resources to be shared with a group of VMs, but it's not that level of sharing what you have in NAS. Okay. So for terminology part, I will be discussing few of the. Just a second.
Sure.
Sorry. Sorry. Okay, so I'll be discussing few of the points here, like what is learn, what is learn masking, and a few of the other terms. There are other terminology available. There are various things you can refer to. I have a section in the reference and mention all the URLs there. You can refer them. So what is learn? Learn is basically, it's the same thing as I mentioned. It's a drive. It's a hard drive what we are creating, and so basically what we do is that once we segregate the drive and create multiple section, we used to have a logical numbering system there from the storage, from the SAN storage itself. So to identify each and every unit or each and every the portion of the storage I have allocated to someone. So say like I've created 2 gig of a space that will be used for a host one. That will be something that storage appliance or the storage product needs to name it, and name it with a unique identifier, or so that specific thing is called LUN. And it depends upon how the naming system has been formatted in the storage appliance. So like I have created LUN1 of 2 gig, then again LUN2 of again 50 gig for another host. So basically it's a logical numbering system where you can identify the exact address for that device to whom the interaction will be happening. Okay. So for example, I mentioned is that there's a multi-disk drive which has multiple physical iSCSI ports. So each iSCSI is a different block. It's a different block, and each iSCSI target can be, created as a different LUN. So we'll be having various the representation and the logical numbering for each and every disk, so that if we are having, basically it's for management purpose for the storage side, where I have the exact address for that particular device and drive to be managed. Okay. So is that clear? Any questions?
I do not see any questions so far from the audience. Yeah.
Okay. Okay. So if any question, just let us know. Okay, I'll just move ahead. Next point is the masking, LUN masking. So the ideal workflow is that the storage appliance, like any storage, like NetApp or EMC or some storages, how they create LUN and how it has been exposed to a client. So I'll just give a workflow. So like on storage, I have 4 drives available. So what I'll do is that, and I want these storage to be used by 2 clients. So what I'll do is on storage side, I'll create a volume which can be formed with a RAID or something like that, so that I have a reliability on the drive side. So once that volume has been created, I'll be creating LUNs, and those LUNs will be assigned or mapped to a specific host 1 or host 2. Now on the host side, client, depending upon the operating system, client will be mapping those disks. So like for Windows, I'll be adding that LUN, which will be available in my disk management, and I format that. I'll create some column there, and it is a kind of local storage for my client, and I'll start using the creating files or whatever. That's the whole workflow. So you are aligned with what is happening here. So in the same context, LUN masking is that basically it's an authorization process for security thing, for a level of security that makes a LUN available to only selected hosts and unavailable to others. So this is more like a security thing, and say like LUN1 and LUN2 is only can be utilized by accounts department, and LUN3 and LUN4 should not be accessed somewhere else. Like for HR department should not use LUN1, LUN2, and account department should not access LUN3 and LUN4. So what we'll be doing is that we'll be doing a LUN masking for each LUN to a specific host. Basically, it's mapping. Basically, you can say why masking is why masking term is there is that it is hiding the LUN from other. That's why they used to say the masking. Okay, next, zoning. Zoning is, in easier term, the partitioning FC fabric switches into smaller subnet, where we have defined the routes only for the hosts which are allowed to interact to each other. Basically, what we are doing is that we are having path only for those clients or storage and hosts which needs to be talking to each other and sharing the data. So that's the zoning is all about, where you're creating multiple zone for a similar kind of devices which are allowed to use each other's data. Basically, it only applies to switched fabric topology. The other topology is like peer-to-peer topology, and the other hybrid topology, that is zoning is not applied there. Zoning is of two types, like soft zoning and hard zoning. So in soft zoning, we are only having a configuration on switch with the name service. Sorry, the name service. So what we are doing is that we are doing or dividing the FC subnet with the name service only. And by this, what we are doing is that what we are getting is that we are only have zones for those devices which are allowed to talk to each other. So even if other cluster who is not part of this name service zone, then that person will not be able to recognize whether the storage or other LUNs are available. But this is a bit unsecure because this is based on a name service, and if you directly access the addresses, then you can access them. So that is not the permanent zoning, what we can say, or the more secure zone. Okay, so as I mentioned, that is not secure, the soft one. So hard zoning is more secure because it has been applied with actual hardware implementation, and we are ensuring that from this port to this port, this subnet to this subnet, uh, these are the hosts which needs to be accessed to a specific storage. So in this case, even if you try to access some storage or some host which are not part of this zone, you will not be able to access that.
So, Ravi, I think we can take a
Yeah.
pause here.
Sure.
We
Yes.
have, so we have one question from our audience that
Sure.
so Gayatri is asking that what is the difference between LUN masking and LUN zoning? Zoning also makes sure which host is allowed to access what. So basically, what's the difference then? Masking and zoning.
Yeah, so zoning and masking are two different terminology. So masking is basically how I should say this. There is a authentication and there is a authorization, and there is another term which is called mapping. So LUN masking is basically is that the LUN which is only available to a particular host. And what was the LUN zoning? And what was the second part, Meenal?
So no, basically the question was like, what is the difference between LUN masking and zoning? Because both are like kind of segregating or hiding, right? So zoning is also making sure that host is not allowed to access what.
I'm not sure if the LUN zoning have been applied on the storage side, but zoning what I'm mentioning is it's applied on the switch side. Okay. So here you are interacting with the subnets which will be available on the FC switch only. Okay.
Right. So I think So in that context, zoning will be applied to the switches, and whereas the masking will be applied to the HBA level. So
correct. Yeah. It's more like on the storage side on HBA level. That's what this thing is. Okay.
So I think, and in the context, if we see in the real life scenario, so I think zoning will get applied first, and then after segregation will be LUN masking.
Yeah. Right. Absolutely. Yeah.
So, Gayatri, does that answer your question? Oh, she's saying yes. Okay. Sure. So, thanks, Ravi. We can go ahead.
Yeah. So continuing with that, there are a lot of things we can walk through, but like WWN, WWP, and WWNN, those are the unique terms. Basically, it's a unique format, a unique identifier format to identify a device. So if it is a node, then we used to call it like www node name, and same goes for it. It's a port. It's it's WWPN. Basically, it has a format which has like company name. It has a unique string which has been allocated for the device. There are hardware MAC association also is there. So it generates a unique and identifier which is unique in all over the world. So just this is just to ensure that the communication which has been taking place, it's unique all across. Okay. Okay. Any more question here so that I can move next for how will be accessing client?
No question. No more questions.
Okay. Okay, so discussing about the how we'll be accessing the SAN from the clients. So, like as I mentioned here, we have iSCSI ADM module or package available on Linux. So what you can do is that you can find iSCSI ADM in YouTube -D discovery to find out a specific LUNs which are exposed to your current host or current client. You can do login iSCSI login from that iSCSI ADM command. But I suggest everyone to go through the iSCSI ADM utility, do a man page, and see what are the options are available. So what you do is that you on the Linux side you do iSCSI. I'm discussing about iSCSI. So you do iSCSI ADM and discover the learn. If you want to create a file system, you add you do MKFS and create a file system on that learn, and you mount it locally to use that file system and start using the learn. There's another Red Hat is having that utility that rescan SCSI bus asset that also shows you what are the available disks or the LUNs to that host, or recently added host or LUNs. So you can do fdisk and you can see what the LUN is formatted, mount it, and start using it. While on the Windows side, everyone should be using that iSCSI initiator application. We can do the from the CLI PowerShell as well, but that is fairly easy and simple straight. Like iSCSI initiator application, in that you can find out the target for a particular server. So like my server is 172.1.1.1, which has been giving me this LUN1. So what I'll be doing is that I'll be adding that particular IP in the target and trying to search what the LUNs are available. So once the scanning is completed, that LUN needs to be logged in. So you can log into the LUN. So then LUN is available to you as a disk. And after that, you go on the disk management side, and you'll be seeing that a disk is available there, and there you can format and start using it. Yeah, so that's also set for the assignment as well. Do ask question. So the assignment, I just discuss the assignment, and after that I'll wait for questions. So assignment is, what you can do is that you can create a freeness server setup, create one iSCSI LUN, and have a Linux client and a Windows client, and mount that LUN and try to run few of the IO tools like FIO or VD bench to create big number of files and see how this whole process happens. So this will be a good assignment for everyone. Try and if you still find any type of questions, queries, Meena will be sharing the email address where we can send out your queries. So questions?
Okay. So I think we have one more question from Divya. So the question is like, don't we require initiator group for the LUN mapping? Is what question.
So initiator group is so your iSCSI initiator application is there. So there as soon as you have added the target, as I mentioned that you need to log in, then that group is is available on the server side itself, and once it has been authorized on the server, then that used to be so-called login or online, and then only it will be available and ready to use. Okay.
So yeah, I think those are called I groups, right? So I think we can have the lunch to the I groups.
That is a specific term, I group way of the. You can refer that, but I was just talking about the generic terminology.
So I think I'm not sure. Like, does that answer your question, Divya? I don't see any response, so I'm assuming it does.
Okay.
Yeah.
So for everyone, I've mentioned here a lot of.
Sorry to interrupt, Ravi. So yeah, sure. So there is like a follow-up question on that same question. That is, can we apply IG to multiple learns?
I don't think so. No, I don't think so, because one I group you have created on the storage side, that will be mapped to a particular LUN, and that LUN will be usable by a particular host.
Okay. Any more questions? Okay, I think.
Cool. So what I was mentioning is that I have just mentioned here the reference point here available for like few of the topics, and this will give you some insight where you can walk through and understand the block level SAN and how the lens can be detected on the Linux side, those stuff. So that is pretty useful. And if you have any queries, just feel free to drop a note. Okay. Yeah. So like Ravi mentioned, please do feel free to write us at learning@afourtech.com, and also try to complete the mentioned assignments, and like while completing those, any queries related to SAN or any regarding any previous topics we covered so far, please do feel free to write us. And thank you, Ravi. Indeed, it was a very informative session. I think our audience will get benefited from it. So yeah, so we do looking forward from your queries and maybe the completed assignments. Yeah. So if there are no more questions, I think we can call it a done. Sure. Thanks for the time. Thanks, Pina. Thanks. Thank you all.